To find the general solution of the ODE, the derivative of y with respect to x plus 3x squared y is equals to exponent of minus x cubed sine x. We note that this differential equation is a linear first-order ODE. It is of the form the derivative of y with respect to x plus p of x multiplied by y is equals to q of x. To solve differential equations which are of this form here, we can use an integrating factor. The integrating factor of this differential equation here is mu of x is equals to exponent of the integral of p of x with respect to x. And when you multiply the linear differential equation by its integrating factor, then it will simplify to the derivative with respect to x of mu of x multiplied by y is equals to mu of x multiplied by q of x. Now, by comparison of these two equations here, we see that the coefficient of y here is a p, and the coefficient of y here is 3x squared. So we have our p of x there is 3x squared. Then by looking at the right-hand side of this equation here, we are having q of x. On the right-hand side here, we are having exponent of minus x cubed multiplied by sine x. So by comparison, we see that q of x is equal to exponent of minus x cubed multiplied by sine x. So using the p that we have just found here, we can go on and find the integrating factor. So we have our mu of x is equals to the exponent of the integral of 3x squared with respect to x. And the integral of 3x squared with respect to x gives us an x cubed. When we are evaluating the integrating factor, we do not add the constant of integration. So we have our integrating factor there is exponent of x cubed. Then we go on and use this formula because we said that our differential equation will simplify to this form when we multiply it by the integrating factor. So we have our mu here and we have our q here. So using this formula here, our differential equation simplifies to the derivative of the exponent of x cubed multiplied by y with respect to x is equals to exponent of x cubed multiplied by exponent of minus x cubed sine x. But this part here where we have exponents, we can simplify that by using laws of exponents. Exponent of a times exponent of b is equals to exponent of a plus b. So in this case, we'll be having x cubed minus x cubed, which will give us a 0. So we'd have exponent of 0. Exponent of 0 is a 1. So we'd have 1 times sine x. So the right-hand side will become sine x. So that's the differential equation that we have. We now go on and integrate both sides with respect to x. But when we are looking at the left-hand side here, we are having a derivative of a function. When we integrate the derivative of a function f of x, the result that we get is f of x. So in this case, we are differentiating this part here, then go on and integrate it so that when we integrate, we just remain with this part exponent of x cubed multiplied by y. Then for the right-hand side, it will give us the integral of sine x with respect to x. Then when we integrate sine of x with respect to x, it gives us minus cosine of x plus c, where the c there is a constant of integration. We can then go on and make y subject of the formula. We divide this whole equation by the exponent of x cubed, and we get that y is equal to minus exponent of minus x cubed cosine x plus c exponent of minus x cubed. So what we are having here, that's the general solution of the differential equation that we were given.